Hi everyone, today we're going to talk about AP Precalc 1.7a, rational functions, and end behavior. Let's get started. So we start off with the domain of rational functions, and we're just going to go through some examples to show all the minor points so you can understand how to solve these problems. So first up, we have f of x equals x squared minus 4 over 3x plus 12. So this is just how the graph looks like, but we're going to take a look at the denominator. We're going to set it equal to 0 because when the bottom is 0, it's undefined because you can't divide it, so that's how you know it's an asymptote. So you solve and you get -4, and that's just saying that it's going everywhere left to right but -4. So how you put it in the format is negative infinity, -4, u, -4, infinity. Then we're going to try another example. So same thing, g of x equals 4x minus 1 over x squared minus 2x minus 24. So we're going to set the bottom equal to 0, but for this one, we're going to need to factor it to solve. So you end up getting x minus 6 and x plus 4, and then you set those equal to 0, and you'll end up getting 6 and -4. And then you're going to do the same thing, and you're going to plug into the same format that we use. So you have negative infinity, -4, u, then you have -4, 6, u, and then 6 positive infinity. Now we're going to take a look at how you can tell with the graph. So we're just going to draw out an example graph, get all the lines in, and it's going to show us where the asymptotes are, and we're going to make the domain based off that. So what it's saying, it's going to be everywhere left and right but where those two asymptotes are, so it's 5 and -2. So same format, negative infinity, -2, u, -2, 5, u, 5, infinity. Okay, now we look at end behavior. So for these, in this section of the lesson, we're going to basically tell based on the graph, but in the next section, you'll learn how to tell it without. So we take a look at the graph, and it's going to positive infinity, it's going to infinity, and then when it's going to the negatives, it's going to negative infinity. So that's how you know it's that. This is just based on flicking on the graph, and you're going to learn how to do the next one next. So this is how you tell with the table. So here we're going to plug some numbers in. Going up, we're just going up by tens because it's easiest. And those are just numbers. Sorry, they're a little hard to tell. But if you can't see very good, can't see the numbers, it's going to 0. It's going down to 0. And then here are basically the opposites. So this way we're getting smaller each time. The first one we were getting bigger each time. And as we get smaller, we're also approaching 0. So that means this function, I forgot to write the equation, but this function is approaching 0. So what that means is that in the previous equation, we have lim equals negative infinity or positive infinity. This one we're just going to have 0. So as it's going to negative infinity, it's 0. And as it approaches positive infinity, it's also 0. So that's how you know for that one. And then here is the next example graph. What we're doing with this one is we're going to have a horizontal asymptote as well. This is how you tell what it approaches. Like the top one, the 0 would be a horizontal asymptote. So the vertical asymptotes with this one would be x equals -3 and 3. Oops, I wrote 2. -3 and 3. And then horizontally, it'd be -2. As you can see by the line there, sometimes it's hard to tell, but basically, the -2 in this situation is the 0 in the last one. So you're going to go ahead and write out the same format, lim f of x equals -2 as it's going to positive infinity, and then lim f of x equals -2 as it's going to negative infinity. So that's basically that section. You tell by the horizontal asymptote. That's like the main point. Thank you guys so much for watching. I hope that this helps.